Alright, so I guess the first thing we should learn about is the concept of a limit, because a lot of calculus is based on the notion of a limit. So, the limit, what's a limit? So, what's a limit? Well, the limit of a function is informally the height of the function where the graph is approaching. So, formally, we denote this by lim. This is like notation, and we have an x with an arrow going to c, and this reads as the limit as x approaches c. And then on the right side here we have a function. Since we're in x, it's going to be in terms of x. So it's a function of x, and this is going to equal to big L, and this L is our limit. That's our limit. And C and L are, well, this is really unnecessary, but C and L are members of the real numbers. So what does this mean? It means that if we have a graph, say, I'm going to make a generic graph here. I'm going to make it curvy. It has a cusp here, but whatever. Functions can have sharp points. So if I have this point C here on the x-axis, so at each point x, the height of this function is f of x. So at f of c, this is going to be the y-coordinate right here. This is going to be f of c right here. So the limit is the value of f of c as it approaches c. Notice how I say it approaches c. It doesn't actually hit c, so we're not technically evaluating. This is not the value of f at c. It is the value of x, f of x, as x is getting infinitely closer to c, but not actually hitting c. And you might say, well, that sounds like a really stupid definition. Like, why would we need that ever? So I'm going to try and give you an example of why the definition of a limit is useful. Alright, so let's consider the function y equals x squared minus x minus 2 over x minus 2. So this function is what we would call a rational function if you took pre-calc, and you might be noticing that we can factor the numerator into two binomials, namely x plus 1 and x minus 2. And so we can cancel these x minus 2 terms out, and we're left with x plus 1. So the graph of this function is going to be quite similar to the graph of x plus 1. In fact, it is exactly the same at all points except one little point here. And this is going to be when x is equal to 1. I mean, x is equal to 2, sorry. So this hole exists when x is equal to 2. And so this y value is f of 2. But why is there a hole? Because if you plug 2 into this, you're going to get 0 over 0. So that's why there's a hole. It's undefined. So why do we need a limit? It's because we can evaluate the limit as x approaches 2 of this function, which I'm not going to rewrite, and that is going to equal 3. And why is it 3? Because this is actually one way of evaluating limits like these. You can't directly put in 2, but if you cancel out these x minus 2 terms, you get x plus 1. And then when you substitute 2 into this, it's 2 plus 1 equal to 3. So one way of doing limits, calculating limits, is to use direct substitution. And when it doesn't work, you can use several different methods. You can use canceling out like this. You can use adding by conjugates if you're dealing with square roots and the like. Or you can use something called L'Hopital's rule, which I'll get into. I don't know when. Might not be now, but definitely down the road. So if we tried to just calculate f of 2 here, we'd be stuck because we don't know how to do that. We can guess what it might be if we made a graph like this, but there is no answer to f of 2 because it's undefined. But we can take the limit as x approaches 2. We can take x values 1.9, 1.99, 1.999 on the left and on the right, from the right, so 2.1, 2.01, 2.001. And we can calculate f of 1.999 and f of 2.001 and say, okay, so from the left, f of 2 is approaching this value, and it's approaching the same value from the right-hand side, so that must mean that the limit as x approaches 2 of f of x must be the value that's being approached from the left and the right. And that's the key thing. This limit, the limit of x approaches 2 from the positive side, must equal the limit as x approaches 2 from the negative side. This is the negative side, so this is the negative side, and this is the positive side. They must converge to the same value, the same y value, or else the limit does not exist. Of course, you can calculate left-hand and right-hand limits on their own, but the total limit will not exist if they are not the same. So if the left-hand limit does not equal the right-hand limit, the whole limit does not exist.